Structure of metals. We know that metals are in general solids. Solids can be either crystalline or amorphous. Metals have crystalline structures. We know that metals have unique characteristic properties of their own. While discussing the chapter metallic bonds, we studied that the unique properties of metals like malleability, ductility, high tensile strength, conductivity, and many more give us clue about the existence of very strong metallic bonds. To form such strong metallic bonds, atoms in metals should be packed together as closely as possible. And there can be several packing arrangements: hexagonal close packing and cubic close packing. These are the two main kinds of arrangements. Let's briefly see the close packing arrangements. Firstly, hexagonal close packing arrangement, or HCP. This is how a hexagonal close packing structure comes out. If we stack up the atoms layer by layer, four atoms at the bottom, and when we put the atoms in the next layer, we can see that they'll be adjusted in space that is found in between. And this is how it goes. Hexagonal close packing, or HCP. This is how it looks. Let's move on to cubic close packing. We know that a cube has 8 vertices, 12 edges, and 6 faces. If we put 4 atoms at the bottom vertices and 4 atoms at the top, this is how cubic close packing, or CCP, structure looks like. Metals come in any two type of the following cubic structures: body-centered cubic structure and face-centered cubic structure. Body-centered cubic structure, or BCC, face-centered cubic structure, or FCC. Let's see how a body-centered cubic structure looks like. In body-centered cubic structure, each atom is surrounded by 8 others. That is, for every atom at the center, there are 8 immediate neighboring atoms. A body-centered cubic structure has 8 vertex atoms and 1 body atom in the center. We can see that due to 1 atom at the center, vertex atoms do not touch each other, but they all touch the body atom at the center diagonally. This is a space-filling model. This model is called a space-filling model. Let's see another model called ball and stick model to understand the existence or positioning of the atoms clearly. Okay, let's construct the cube. First, one face at the back, one in the front, and let's connect the 2 faces by the 4 edges. Altogether, we can see there are 12 edges and 1, 2, 3, 4, 5, 6 faces. And 1, 2, 3, 4, 5, 6, 7, 8 vertices. This is a cube. Let's start putting the atoms one by one in each vertex. 1, 2, 3, 4, 5, 6, 7, and 8. So 8 atoms in the vertices and 1 atom at the center. So this is how a body-centered cubic structure looks like. However, we can see that the vertex atoms do not touch each other, but they all should be touching the body atom, which can be clearly seen in this space-filling model. Let's now move on to the face-centered cubic structure. In this, there are 8 vertex atoms and 1 atom each at the center of every face of the cube. That is, 8 vertex atoms and 1 atom each at the center of every face of the cube. Each face atom touches the vertex atoms diagonally. We can see here each face atom touches the vertex atom diagonally. Vertex atoms do not touch each other, but they touch the face atoms. We can very well see here the vertex atoms not touching, but they touch the face atoms. Face atoms touch each other. Now, let's once again try the ball and stick model to understand the positioning of the atoms better. Let's construct a cube first. The first face of the cube, one more in the front, and 1, 2, 3, 4 edges that connect the two faces. We can clearly see the 8 vertices, 6 faces, and 12 edges of this cube. Let's start putting the atoms in the vertex. 1, 2, 3, 4, 5, 6, 7, 8. Now we should be putting the atoms at the center of each face. 1 at the center of top face, 1 at the bottom surface or bottom face, 1 in the front, 1 in the back, and 1 each on the sides. So 6 atoms at the center of each face. The vertex atoms do not touch each other. The body atoms touch the vertex atoms diagonally, and they also touch each other. The face atoms touch each other, which can be clearly seen in the space filling model. Let's summarize. Summary. In metals, atoms are closely packed in the form of hexagonal or cubic structure. There are 2 types of cubic structures, namely body-centered cubic structure and face-centered cubic structure. Body-centered cubic structure, BCC, and face-centered cubic structure, FCC.